Hello and welcome to another episode of hybridization. Today in this lecture I'm going to tell you the structure, not the structure, the geometry, and first we'll deal out with the table. If you know the table, then you'll be easily able to solve the problems. I hope you've seen the part 1 video of hybridization. Before studying this, you should study that because I've given the formula in that. Okay, so number of hybrid orbitals, as we've calculated in my previous videos, that we've seen the method to calculate the hybrid orbitals. So what kind of hybrid orbitals that we can get? There are many cases. The first case is you can get it as 2. Number of orbitals can come out to be 2. Okay, and then we will see another, the hybrid orbitals can come out to be 3. Okay, there's another case, hybrid orbitals that can come out to be 4. Okay, then we'll see another case that will be 5, and then another case here that will be 6, and then the last case will be 7. These are the number of hybrid orbitals that we can get. Okay, now supposedly if you solve by the formulas that I told you in the last video, you'll your first step is done. That is the number of hybrid orbitals that you've got. Okay, now I hope you've calculated the lone pair also. What could be the lone pair in this case? Then we'll see the hybridization. Okay, lone pair could be only 0. You'll always get 0 lone pair in this case. Okay, in case of 3, there are 2 possibilities. Okay, 2 possibilities in third case. One would be you will get 0 lone pairs, and another case would be you will get 1 lone pair. Okay, no need to learn this table. You just have to remember that if you are getting, you'll easily be able to solve it if you just see this table once. Okay, in fourth, when you have 4 hybrid orbitals, then there are 3 cases. Either you'll get 0 lone pairs, or you'll get 1 lone pair, or you'll get 2 lone pairs. Okay, in case of 5, you will see that you'll get either 0 lone pair, 1 lone pair, 2 lone pair, or 3 lone pairs. In case of 6, either you'll get 0 lone pair, okay, or you will get 1 lone pair, and at max you will get 2 lone pairs. Okay, and in the 7th case, it will be you will get 0 lone pair or 1 lone pairs. Okay, this is the first, to see the table how I'm forming it. Okay, then you write it down. First understand, first watch this video, then write it. Suppose you've got the number of hybrid orbitals as 2, and then what should be the hybridization? Simply s to the power 1. First you're going to fill s, then p. SPDF, this is the procedure that we are going to follow. Okay, let me remind you, we are going to follow this method, SPDF, this procedure. First we'll fill S, then P, then D, and then F. Okay, and so S, then P will be P to the power 1, S1, P1, that is 2 hybrid orbitals. Combination of 2 hybrid orbitals gives you 2. Okay, 2 SP hybridization. And in this case, if you have 3, then what should be the hybridization? It will be simply s to the power 1. First you want to fill s, then p, and for p there's only 2 positions. Okay, 2, s, p, 2. Okay, but that this means what? Are you understanding that the combination 2 hybrid orbitals, that means you're combining s plus p or p. 2 orbitals are combined and it's forming 2 hybrid orbitals sp. Okay, that means 2 bonds will be there, that will be sp bonds. Okay, then in this case s plus p is giving you sp2. Okay, then what should be the case in s4 hybrid orbitals? It will be what hybridization? It will be sp3 hybridized, sp3 hybridized. Okay, what in case of 5 hybrid orbitals? It will be either it will be sp3 3 plus 1 4, and then 5 D1, that will give you sp3 D. Either it will be this, or the hybridization is going to be the same, the structure is going to change. We'll see. Okay, in this case, in 6 hybrid orbitals, it's going to give you sp3, 3 plus 1 is 4, 5 6, that is D2. Okay, here also sp3 D2, sp3 D2, and here it will be sp3 D3, sp3 D3. Okay, now we are going to form the structures. First, we have supposedly if you get 2 hybrid orbitals and 0 lone pair, then the angle will be 180 degrees. Obviously it's showing that there is no lone pair present in the compound, and it's going to be straight, that is linear. The shape will be linear, so the structure should be like this. Okay, let's see some examples. Its example will be what? First example could be like BeH2, okay, or you can see C2H2, okay, it's in the plane, okay, and CO2 is the best example. CO2 is the best example. Then should be I hope it's enough, HgCl2 also you can see here. Okay, so this is our first case. Let's see another case. Another case is for 3 hybrid orbitals, and the hybridization was sp2, and we have 3 times this, 3 bonds which are going to be sp2 hybridized, and you have 2 cases here with the 2 lone pairs. Either you will have 1 lone pair, or you are going to have 0 lone pairs. So if you have 1 lone pair, then obviously you have 3 bonds that are going to be sp2 hybridized. Then what should be the structure? Simply this. There is no lone pair that is going to, if there would be any lone pair, it's going to push these bonds to some angles, but there is no lone pair. And what is the angle between these bonds? It is 120 degrees, and this looks like as a triangle, so it's going to be, its shape is going to be triangular planar. Okay, so, and example would be, the best example is BF3. If you calculate for BF3, you will get this only, triangular planar. Then it's all about, no need to learn these, you just have to remember the formula that I told you in the previous video, and after seeing that you can solve it. Then it's C2H4, SO2, SO3, there are many examples. Okay, now let's do for another one. That is, if you get 1 lone pair, that means either of these 1 bond is going to be a lone pair. There is no bond present, but there will be a lone pair. It should be like this then. 1 free lone pair is present there. So this lone pair is going to press these 2 bonds more down. Okay, and what kind of structure is this? This is simply bent, or you can say it is V-shaped. It is V-shaped. Either you can call it as V-shaped, or you can say it as it is bent. Bent is generally used. Okay, so the example for this is simple, SO2, okay, and SnCl2. SO2 is not here, okay, SnCl2. These are the examples. And if you don't get it here, if I'm getting it wrong, you can calculate for these, and you will receive you will reach at this point only. This is going to come as 3, and 1 lone pair will come. Then obviously you'll understand that this is going to be the structure. Okay, now another example is this one. Let's see, 4. I hope you are finding it easy, but they are very easy to solve. So 4th, when you have 4, that means you are combining 1s plus 3 times p. It's going to give you what? sp3 hybridized 4 times. That means 4 bonds are present with sp3 hybridization. You need to form 4 bonds in space. Okay, from the center it should have 4 bonds in space, and with 0 lone pairs. That means what kind of structure it's going to have? It's going to have a structure like this: 3 bonds at the bottom, 1 bond at the top. As you can see, at the bottom you will have a triangle formed. It's like a tripod. I hope you've seen the tripod in your college, in your lab. So you'll have a triangle at the bottom forming a triangle, 3 bonds in the plane, and for not in the plane exactly, they are just pointing towards the 3 points in one plane. They're forming a triangle at the down, and at the top you'll have 1 bond. So what should be the angle between these, any of the 2 bonds? What should be the angle? The angle would be 109 degrees 28 minutes. These angles you'll have to remember. Okay, so this is the shape and this is the angle, and the example you can calculate for anyone. CH4, CCl4, CCl4, okay, SnCl4, and then NH4 plus is another example. Okay, let's go for another one. Suppose you get 1 lone pair, then what is going to happen? Any of the bonds, you have to remove 1 bond and put a lone pair there. Let's form structure. 1 lone pair at the top. So now the shape is what? What can be the shape of this? It's simple triangle at the bottom. So its shape is going to be trigonal pyramidal. Trigonal pyramidal. Okay, examples are very simple. PCl3. I hope you're not learning these examples. You just have to calculate the values for hybrid orbitals and lone pairs, and you will arrive at these structures easily. H3O plus. Okay, we've done this earlier also. H3O plus, and in that case we got 1 lone pair and 4 hybrid orbitals. So we can see hybridization was for sp3 and lone pair was 1. So 1 lone pair at the top, and it's gonna form triangular pyramidal. Supposedly if you get 2 lone pairs, then you have to remove another bond from here and form and get a lone pair there. So the structure is something of this sort. You'll have 1 lone pair here and another lone pair here. So this is looking as bent shape. So this is water, example, H2S NH2 minus. Okay, I hope you're finding it easy. Let's go for the 5th one. When you have 5 hybrid orbitals, obviously you'll have the lone pairs coming up as 0. Now you are asked to form 5 bonds in the plane, not in the plane exactly, from the center you need to form 5 bonds in the space. Okay, so how are you going to form the structure? The simplest structure will be like this: 3 in the plane and 1 bond at the top and 1 bond going down. This is for this 0 lone pairs. 5 bonds from the center to this point, and this point. 3 bonds in this plane, 1 bond at the top and 1 bond in the bottom of the plane. So what kind of structure you can see here? It's simple. It is trigonal bipyramidal. Trigonal bipyramidal. Example is PCl5 and PF. Okay, 5, anything. So what is the angle here? What angle you can see here is, what angle is present? You have 120 degree here and 90 degree here. So 90 above and 90 down, and 3 120 angles in the plane. Okay, and one more thing you need to remember, that these are the positions which we call as equatorial bonds. Okay, the bonds which are in the plane are called equatorial bonds, and the bond, because they are at the equatorial, okay, and the bonds which are present at the top and the bottom are known as axial bonds. Okay, let's take another example. If you have sp3 hybridization and 1 lone pair, now what you have to do is you have to remove any one of the bonds from here. So how can you remove 1 bond? Let's see. The structure is very simple. First you will always remove the bond from equatorial position, and then on from the axial positions. Okay, so the structure will be very simple. This thing here, the same, above and down, 1 lone pair in this plane. Okay, what kind of structure it is? It is simply a seesaw structure. Seesaw structure. An example is SF4. Okay. And the next thing is you can have is for 2. Now you need to form another structure in this only, and you have to remove one more bond from here, and you have to put a lone pair there. Then how are you going to do it? It's very simple. Remove one from now actual position. This was here, another here, one bond is left. This kind of structure you are going to get. Now it's simply what kind of shaped? It is forming a T here. You can see it is forming a T here, so it is called T-shaped. These bonds are not exactly straight 180 degrees because these lone pairs are going to push them below. Okay, this is not exactly 180 degree. Okay, but it is around 180 degree. It is T-shaped. Okay, let's deal out with the third one. There is no need for examples. You can just, if you get the question, you can derive the structure, geometry of it. If you get it as 3 lone pairs, now what? You have to remove one more. Since the earlier structure that we got was like this, I hope you remember. The first structure that I drew here was with the 0 lone pairs. Now in this structure, you need to remove all 3 bonds and put lone pairs there. So you're going to put a lone pair here, a lone pair here, and a lone pair in equatorial positions only, and these are the 2 bonds. So it is what kind of structure? It is simply linear again. Okay, examples I3 minus, these are the best examples, and these I asked in exams also, ICL2 minus. Okay, and now with 6 as a number of hybrid orbitals and 0 lone pair. Now you are asked to form 6 bonds. So the simplest example would be what? Simply form from the center, make 6 bonds, 4 in the plane and 1 top and 1 bottom. So you can see it is forming a rectangular here, a square, a rectangle. It's actually a square type. So the structure is octahedral, or you can say it as square bipyramidal. Square bipyramidal. An example is SF6 CRF6 3 minus. Okay, and the symmetrical, stable, less reactive. Okay, it is symmetrically stable. As you can see, it is symmetry. It is forming the symmetry from the center, so it is less reactive. Something which is symmetrical, is less reactive. Okay, now for 1, the structure is going to be what? You need to have 1 lone pair here. Put it at the top. Not here, we don't have axial or that kind of bonds. Okay, equatorial. So this is the thing. This is the new structure. So this is what kind of structure it is. As you can see, it is forming a square here. Square with 1 pyramid with 1 leg. So it's going to be square pyramidal, not bipyramidal, but square pyramidal. Example is IF5, okay, BRF5, okay. Another one with the 2 lone pairs. Again, we'll form this square here, 4 bonds, lone pair at the top and lone pair at the bottom also. So this is going to have just the square planar. It is a planar structure. So the example is XEF4. Let's deal out with the last one, that is with 0 and 7. So the structure here is pentagon. You need to form 7 bonds. First 5 in the plane, 3, 4, and 1 at the top and 1 at the bottom. So it's forming how many? 1 at the center. These are the atoms, position of atoms. Okay, from center it is forming the bonds. So 7 bonds. So the best example is IF7. And one more thing, what kind of angles it has here? There is 190 at the top and 190 at the bottom, and these angles are 72 degrees. Okay, what about this one? It is called distorted octahedral, and these are generally not formed. Okay, now as you can see, what throughout this whole thing, that as we are going down, Okay, as we are going down, the angle is decreasing. Okay, here it was, in the first case it was 180, then 120, then 109 degrees, and then it reduced to 90 degrees, then 72 degrees. The angle is, as you go down the table, the angle decreases. Okay, I hope you liked this video, and please subscribe to my channel, and please give your comments. Then only I'll get to know that how I'm telling you. And thanks for watching.